So big news of the week is Situation Awareness being margin called and being saved by Citadel. And if you want to see probably the biggest drivers, we can look at the HBF stocks, high bandwidth flash stocks such as SanDisk, which has dropped roughly 50% from the peak in roughly a month. And similarly, that's the case of SK Hynix. End of June, it had its peak, and now at the end of July, it basically retraced 50%. Now, there's lots of things we can say looking back in hindsight, but that's not relevant for today. What is important, I think, is looking forward about what this means for HBF and specifically the open models is what I like to focus on. Probably the biggest news of the last few days is DeepSeek V4 Flash. Some of the benchmarks have started to come out. So on artificial analysis, you can now see V4 Flash is sitting very nicely on the Pareto curve. From my perspective, the most interesting model, which I already have brought up and highlighted, is the Claude Sonnet 4.6 Max. So this model performs better according to these benchmarks than a Claude Sonnet 4.6 with max thinking. And for a model that you can potentially self-host, that is extremely promising. Now, what kind of hardware do you need to self-host? So we have, this is from the Dwarf Star repo from Antirez of Redis fame. And he has some very old benchmarks, but nevertheless, it's still very useful. We can see that with the Mac Studio 512 RAM quantized version, we can run this model at around 26 tokens per second with 450 tokens per second prefill, which is more than very respectable and very usable. And I think that's like something to consider as hopefully hardware prices go down over time or it becomes more affordable. Maybe it's 18 months from now, but it means in 18 months, you can very well have a Claude Sonnet level model that is self-hosted for a fairly reasonable price. Reasonable being price of a car, which is probably still too expensive for most users, but that may be a sacrifice that is far more palatable than today's world, where it's nigh on impossible. Like maybe you have to buy something from a tiny grad team, which costs like 75 grand. So the drop from 75 grand to like 10 grand is a massive difference. Now, what else is perhaps driving the discussions in AI today? And I think one of the discussions is about the Kimi K3 and some of the advances there. There was this project from that is called Weight Aware Streaming Tensor Engine, and it showed how you can potentially run Kimi K3 on consumer hardware, albeit at extremely slow speeds at 0.6 tokens per second. One of the interesting things with this one is probably the KV cache situation, which actually came from a paper from 9 months ago, from this one, from Kimi Linear, where they showed that they could reduce the KV cache by up to 75% and boost decoding throughput by up to 6 times for long context of 1 million tokens. Now, this probably didn't get that much attention at the time because this model was actually utterly trash. So we can quickly look at it, but it's probably worth contextualizing what they were trying to do. So let's look at open source models, and what I want to do is I want to select this model, and you'll become abundantly clear how bad this is. So we're going to compare it with my favorite model, Kimi 3.6, and we're going to select the mixture of experts model because they're both mixture of experts models. And if we look at the intelligence, actually, let's look at the, we can look at intelligence. And you can immediately see, well, this Kimi model is rated 9, and that is a far cry from almost every single model. Yeah, the Quen model is 24, and the Gemma for 31 billion is 29. That is a massive gap in terms of performance for a model that is even larger, even though it uses the same active number of weights, right? It's larger by like 10 billion tokens, over 10 billion tokens, and with the same active weights, and it has inferior performance. But one thing to highlight is that for these set of models, so the Gemma 4, 31 billion, and the Quen 3.6, 35 billion, is that the context window is around 1/4 of the size of the Kimi Linear. So that is one of the big changes or big things about Kimi Linear that was very, very different and very, very promising 9 months ago, of course. Now, what does this mean? I think at the time it did not get that much attention because, well, the actual final result, the final product, was not particularly good. But now with Kimi K3, I think some of the thinking and some of the consequences have finally come around. So we now have this kind of lossy KV caching that is like 75%. That reduces the need for large KV caches by 75%. And they've demonstrated it and proved that it can work. So what does this actually functionally mean? This may mean, if we look back at the high HPF stocks, it may mean that, well, we don't need as much reliance on these kinds of stock, whether it's SanDisk or SK Hynix. Now, of course, there's like Javon's paradox where, well, the more efficient it is, it means that you can cram more in. So that's probably the that's probably the counter viewpoints for this. Was as always, just because once you're more efficient, it just means that, well, you're gonna make up and use up that efficiency, which is definitely something to also consider. From my perspective, it will be very interesting to see what happens, as now people can see that this is an effective approach. It's used in Kimi K3. How will it be rolled into future models, whether they are open weights or whether they're used in like the proprietary models that are hidden from people? I think that will be very interesting to see if that means that there's somehow better usage of KV caching, and it may mean that it may mean that some of the smaller models, so like for example, some of the models, open source models on the smaller side, right? Maybe these start to have much larger context windows that are usable and also able to and also able to make use of this technology. It'll be very interesting to see how that changes over time. From my perspective, what I'm looking out for is the changes to the Pareto curve, in particular for these small models. It has been pretty much untouched for a couple months now, and it has been ruled by both of the Quen 3.6 models. Knowing that now we are at 3.7 and 3.8, it will be very interesting to see if there are any further Quen models, or whether there will be a new Gemma model, or whether there will be someone else besides these two that come up and push this curve in a particular direction. So that's what I'm looking out for. Maybe there's a new DeepSeek model that will come out that is of this size. The other thing is, if we look up one size larger, which is borderline of what I can run, but not quite, I think that this side of things is also very interesting, because I think a lot of people still look towards the GPT OSS like 120 billion model, and that is fairly old, or at least it still appears a lot in the benchmark. So you can see it's in the Pareto curve. The Quen 3 Coda Next is from the Quen 3.5 generation, so that is also quite a while ago, so like same generation as this model, the Quen 3.5 122 billion. So I would love to see some changes in this most attractive quadrant that pushes up from these two models that are commonly used as a benchmark. That's something that I would love to see as well. It's very interesting to see these numbers, because I think that the models on the smaller side have now exceeded the performance of these two models. I'll try to show that as well if I can quickly click on all open source, and let's clear all, and look, let's just type in the two Quen models. So Quen, we want to see 3.5 and then we want to see Coda Next, and then we want to see GPT OSS. So if we look at these three models, and let's just throw in the Gemma 4 model for good measure. So if we go to intelligence, I don't think that's the right one. Where is the curve? Well, you can see that it's the Pareto curve on this one is just way off the chart, with these two substantially lower at 24, around the 20s, and this one is at 32 with Gemma 4 model up here. And yeah, this scale is also out of whack, but you can see that it's the optimal number is up there somewhere. So I would love to see the models on the larger side start to challenge the models that are actually in the category one bit smaller, like one category smaller. I would love to see these ones push up a bit more. So those are my thoughts going into the start of August. Let's see what happens to the HBF stocks, and what if there's any change to HBF. It's something to look out for in the future as software improves and changes. Will there be more announcements that are more efficient and have less demand for HBF? Or is HBF going to continue to be a very high demand product that requires a lot of attention, just like the HBM, the high bandwidth memory? That's all I have for you. See you next time.